So up till now we have analyzed the mixing elbow with and without swirler, and you have gone through all the steps, and you have seen that the effect of swirler is that it will enhance the mixing, and also it is because this strong flow, this strong turbulent flow, we don't see any separation at all on these corners, and which is visible here, and so which is can you can this can be seen from here, and you can see that this flow is interacting after this part, and also we have main separation over here, and because of this swirler here, this is enhancing mixing, and it has an effect on the separation and as well as on the heat transfer. Now I want in this video that I want to move the location of this solar geometry to the upward direction. So might be we can put this geometry at the location of, right now it's a 191. So let's say I want to put this geometry at the location equal to 291, and that's about this whole video. And as you can see that I have already created these three cells, and you can put the name as the same swirler, but this time this will be at 291 millimeter, and the previous one was at 191 millimeter, and the same is the case with this name as well, 291 millimeter, and here also same name, which is swirler 291 millimeter. So first we start with the geometry, and once geometry decided, then we'll move to the meshing. This should be now very simple because everything is already said. Might we need to make the some little in the meshing part and as well as in the fluent part. And as far as the CFD post part is concerned, so everything is already said. We have to just drop the another case, and we can compare the swirler at that 191 millimeter height and then swirler at the 291 millimeter. And double click on geometry to open the space claim, and you can see the groups are the name selections for the boundary conditions, and these all are there. The only thing we need to make the change is to move the geometry upward. So first I will try that whether I can make it without changing the anything in the model. Otherwise I have to move the original geometry upward direction and make the changes. So first of all, you have to make the geometry as a transparent, and okay, and then select this whole part and try to move them upward. So you can see that we are able to move them in the upward direction. So the distance, because previously it was 191 and now we are going to make it as 291, so it should be at the distance of 100 millimeters. And I think we are successful in moving this geometry by just moving them, and in this way we are just keeping our boundary conditions intact. Otherwise, if you go with removing this geometry and then creating the geometry, or moving this main geometry which we imported, and then splitting the geometry by the combine command, and then you have to create the name selection again. So this part is successful. I will close this part, and just transfer this geometry in the geometry cell in the meshing app, and double click on the mesh, and now it is opening inside Ansys meshing. And if you go to details, and it is again generating the mesh, and this is the standard procedure inside Ansys meshing. And if you uncheck the section planes and go to details, you can see that we have some issues in the mesh. So these issues might be in the name selections or maybe anything else. So we have to generate the mesh again and have to see that if there is any issue, and if there is any issue, we will solve that issue. But I think that the most probably there will be no issue at all in this case because the geometry was intact. We just move the geometry and it take its shape and its location very nicely and precisely. and therefore just wait for the meshing app to finish the meshing this swirler with a new location inside the mixing elbow. And as you can see that the mesh has been generated, and if you take a look on the section planes, and the same meshing strategy is applied, everything is same, only change is that the geometry location is now changed by 100 millimeters and it is on the upper side, and there are some close vicinity of these blades with this part of the mixing elbow, but that's okay. And now close this application, and we'll move to second part, which is the fluent part. And first of all, right click on the meshing cell and click on update, and just wait for a few moments and this will be updated. So this update is necessary, so there may be some changes it want to make. It may be export the mesh to the fluent, so you have to wait for this app to be completed. And now mesh is updated, so you can transfer the mesh to the setup. And now you can update the setup here as well. So right click here and click on update, or you can click on solution and click on update upstream components. So I think we should update the fluent setup from here, and once it is done, then we can go to the solution tab, and from solution tab or cell we can double click here and start fluent. As you can see that we have this information, and so we have to, it says that it requires user input before it can be updated. So for that, how to address a cell in the current state, click on the blue triangle that is over here, and see what is happening there. So all data is up to date and no attention is required. I think we should double click here and open the fluent setup, but you will lose any data you are getting from the previous solution. So it means that you have to run the solution from scratch, and maybe the old data might help you in solving the case much earlier or much quicker, because already we have initial condition or initial solution field with that swirler, so maybe at different location, but still we have some solution. So, and based on that solution we can get the solution much quicker with the new geometry. But anyhow, because we have some issues, and that issue is most likely to be the issue with the cell zone. So we have to go to the file menu and click on recorded mesh operations and see if there's any issue or not. So I think that there's no issue. Okay, we can with this is not enabled mesh zone name, so I will just pass on run calculations and click on calculate. So first of all, it will initialize solution and then it will solve the case for required number of iterations. But as we seen in the previous case, that around 300 iterations solution will be mostly converged. So we can stop there and we can analyze the results. Now in this time we are going to analyze the two cases. One is the swirler at the 291 and second the swirler at the 191. As you can see that the solution has been converged almost, and if you take a look on these point plots, you can see that these are now straight lines, and therefore I will stop solution here. And now we got the message that calculations are complete. And also I want to mention this thing that right now we are running the solution with the first order upward scheme for momentum, and therefore to compare it with the old case we have to make it second order, then run the solution again. Although my recommendation that you should run the first order scheme with only maybe 50 or 100 iterations and then switch over to second order, but nonetheless we can still do it. And now just wait for the solution to be completed with the second order upwind scheme, and after that we will compare solution with the 191 millimeter height of that swirler, and now this current case is which is when we have the swirler at the 291 millimeter from the base side. And as you can see there, the solution is now, although you can see there are some wiggles in the solution, but that's all about this solution. And you can see the difference over the axis is not more than maybe a 0.2 or 0.1. And the same is over here, because we can see the difference is not more than 0.2. And so I can assume that the solution is now almost a straight line. And the same is the case with the residual. So I can stop solution now. And keep in mind, this is the case when we have the swirler is at a 291 millimeter from the bottom side of the small pipe, that is the inlet of the small pipe. And now I will close the fluent window, and maybe before that we can analyze the results inside the fluent as well. So I can see the results of, let's say, the pressure on the mid plane or the symmetry plane. And this is the pressure difference here. And the second thing is, okay, just make it as a local. Second thing is the velocity control plots. And as you can expect, that there should not be much difference here, as the mixing will enhance the turbulence and our mixing, and this will eventually will make the flow uniform across this outlet part of this mixing elbow. And the next plot is of importance is the temperature plot. That is the most important plot here. And okay, so when we compare them side by side, then we can say anything about that, the effect of the position of swirler on the results. And also you can display path lines, and that is coming from the inlet large and inlet small, and we can skip, let's say, maybe a 5 path lines. Okay, so you can see that this swirler is starting to build up from the here, instead of the previous case it was started from the maybe on the middle side. And you can see the strong swirl flow or the strong vortex, and that is going on the upward direction. So you can notice that one over here as well. Okay, so now it's time to see the vector plots. If they are the flows attached, and I think this is more beneficial maybe, but right now I cannot comment without seeing them on the same graph as of the two cases. So when you compare them in the CFD post side by side, then I can comment further that it is improving results, or maybe it is destroying the results. So without going through that plot, we cannot say anything right now. So maybe results are deteriorating, or maybe they are improving. Okay, as you can see here that we have the more maybe as a reverse flow type, that is the effect of this geometry, not the curvature of the band, and but mostly the flow portion. But you can see that we have the enhanced mixing, the strong mixing in this region here, as compared to the previous case. Okay, now I will close the fluent window, and I will open that case in the CFD post. And now you have the choice that either you can compare all three cases in one window, or you can compare only the two cases, that is the swirler at 191 and swirler at the 291 millimeters from the bottom side. So I guess that right now we should compare the two cases. So for that, I will duplicate this results cell, and I will input these results first, and then this swirler also. So the difference between these two cells is that from these two fluent cells is that they both are having the swirler, but one is at 191 millimeters and second one is a 291 millimeters. So double click here, and this will open the CFD post, and it will load the results, but it will keep the same plots as we did with the previous cases. Both cases are open in CFD post. The only thing I can notice here that we should make them as a solid also, these wireframes for the swirler part. So I have to display the pressure side, suction side, trailing edge, leading edge, and hub. And now you can notice the difference between these two geometries. The one of them is at the 291 millimeter, second is at the 191 millimeter. And now you can notice the difference in the pressure contours. First the temperature contour, and second is we can play with the pressure. And you can notice that this pressure is felt in the large diameter pipe as well, which is in the round section. And next thing is the velocity control plots. And again we can see the almost same thing. One is that it is on the lower side, therefore the pressure, the velocity contours, they are felt up to the end part, and then after that there is a less stress of these values. But you can see that now from here we have the influence is felt up to the middle part of the geometry. And if you compare them on the line basis, which is the line right now is at the 48 millimeter, 48 inches from in the y-axis. And if you plot them on the chart, you can see there's some difference in the results. But I don't see the much difference here. And this is in terms of temperature. And we can plot, let's say, the pressure and velocity. So basically, if I decide about these things, so I can say that the difference in the results is not as we thought about, that they will make the much difference here. And you can see that the temperature is slightly different. Maybe in the first case with the swirler on the bottom side, we have something like this. And one more thing is that I can see that the streamlines. So let's say I can plot the old case here and hide these control plots. So you can see that we have the more swelling effect is felt in the upper part of the geometry, and as you can feel from here. And if I display only these path lines from the small pipe, in that case you can visualize them much more clearly. So inlet small for both cases and apply. So this is the effect of this pipe at this swirler at the 191 millimeter in the small pipe, and this swirler at the 291 millimeter from the bottom side. And you can see the effect of this one. So I can see that the more pronounced effect is case when the swirler is at some lower height. So that's about this whole case about the mixing elbow with the swirler. And this is a one addition from my side. If you see them in some standard cases on the internet, you won't find this thing in any one of these tutorials. Even in the Fluent tutorial directory. But you will notice that the thing here is that which makes the things different here in the rest of the workshop is that we started from the one figure, that is the figure of that mixing elbow and some boundary conditions, and then we built up the case from the geometry, then making the symmetric model, half model, full model, and making the proper meshing with the inflation layers, and then solving the case in the Fluent with the appropriate settings in the solver, and then analyzing them in the Fluent and also in the CFD post. And then the next thing which is innovative here is that we have introduced this geometry generation process. Now we have you have the ability or the skill that you can create the geometry of your own, and maybe in the future we can move this geometry, we can make this geometry rotating and with some certain RPM, and this also enhances the more mixing and the more turbulence. So that can be done in the future workshop. But you see that the skills you have acquired is very valuable here. Now you can make your own geometry of any shape of this aerofoil of these blades, and maybe they have some angle, and you can also reduce the radius of this hub as well. So now it depends on you. that how you use these skills for your particular problem, but the necessary learning is already transferred to you. So with this I will thank you, and now this is the time to